Good afternoon, Gators. Today I want to talk a little bit about sig figs. And basically in like math class, you might have a number like 43.2 and you just use that number and you go with it. But in science, the numbers we have are generally measured values from like some experiment that you ran or something like that. And the like number of significant figures or the precision of the number relates to the measuring tool that was used to get the data. For example, if I have some water, which I colored, and I put it into this container, there's no measure on the container telling me like how much stuff there is. So I can kind of look in there and eyeball it and say, oh, well, maybe that's about 40 milliliters, maybe, plus or minus. But that's a very rough number. I can't really be precise in terms of the terms. Now, to be precise, the tool we use in chemistry is generally a graduated cylinder. But again, there are different types of graduated cylinders that get more and more precise. So here's a 100 milliliter graduated cylinder. And again, I put a little color in the water so you can see it better. But if you read up here, it shows each milliliter on the cylinder. And if you read through, you read to the bottom of the meniscus, and you get about a volume of 32.5 milliliters. So you can read to 32, and then it's halfway between the 32 and the 33. So you kind of estimate that last sig fig. So you get about 32.5. If we have a 10 milliliter graduated cylinder, here they actually have increments in between the milliliters. So we can read up and see that it's above the 4, and then it's somewhere between the 4.1 and 4.2, so it's about 4.15. So given that there are more increments on the measuring tool, our number can be more precise. So in this first case, we had maybe 40 milliliters, one sig fig, really rough estimate. Here, with a more precise measuring tool, we have 3 sig figs, 32.5 milliliters. Here, with more precision, we have more precision after the decimal. 4.15 would be the number. Okay. So when we're looking at numbers, there's some rules that we have for sig figs. So sig fig rules. First off, all non-zero integers count. So if you have the number 123, that is 3 sig figs. 1, 2, 3. Okay. Second rule is captive zeros count, which is also known as the sandwich rule. So if we have 203, the 2 is significant, it's a non-zero integer, the 3 is significant, and in between there's a 0 that's captured between the two, so it's significant as well. So it's 3 sig figs. Number 3, trailing zeros count if a decimal is present. So 100 with a decimal there, the decimal means it's exactly 100, and those 2 zeros count, so 1, 2, 3, 3 sig figs. Now leading zeros do not count. So for example, 0.002, because these are leading zeros in front of that 2, these are just placeholders, basically. They don't count. There's only 1 sig fig. So with that, I thought we'd go through a few examples. So 2112, okay? It's all non-zero integers, so 4 sig figs. This one, 2010. Here, the 2 counts, the 1 counts, this 0 is between the 1 and the 2, it counts, but this is a trailing 0, it does not count. So this is 3 sig figs. Here, same thing, you have 2 trailing zeros without a decimal, so 2 sig figs. Here we have the same number, but there's a decimal, which means that it's not just about 2300, because 2300 means it could be 2310, it could be 2320, it could be 2312. It's just in the vicinity of 2300. This means exactly 2300 to that point. So 4 sig figs. Now again, this is leading zeros after a decimal. These are placeholders, so only the 23 here counts. So 2 sig figs. Finally, here we have a leading zero that doesn't count, 2 integers that do count, and then trailing zeros after a decimal that do count. So 4 sig figs. All right, so that's a little bit on sig figs. So enjoy.